Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome every member into our discussion for today. And today we're going to look at an interesting part of the concept of increasing and decreasing functions. And this is going to be culminating into some of the, results which we are going to come across, especially under the analysis of such a kind of graphs. And they're going to be assisting us try to interpret basically two basic theorems, which are going to be very fundamental under the concept of calculus. And these are going to be the mean value theorem and Rolle's theorem, which is going to be a special case of the mean value theorem. And of course, we're going to see that in order for us to understand those two theorems which we have, just mentioned, this specific aspect of increasing and decreasing function is going to be creating a basis for us. Now, in this particular case, I've just given two specific illustrations for the two graphs and the last one. And of course, I'm going to be using them in order for us to try and interpret this specific aspect of an increasing and decreasing functions and how we can represent them appropriately. Now, in this particular case, I'd like to request our members to be kindly checking on description boxes for various links of other videos. We have already come across these two specific terms in some of our areas under the differential and integral calculus, and that is going to be assisting us in trying to find out what basically we had to say on these two specific concepts. Now, in a sense, this is going to be a review of what we have just discussed, and in a sense, we are going to do a comparison between the mean value theorem and the special case of Rolle theorem and try to see what are some of the connections which are going to be existing between the two. Now, we're going to consider a real function which can be given in terms of f, whereby we are going to have f as a function given in terms of this specific notation. And we're going to have this specific f which is defined between intervals which we can give as such. So I'm going to be giving these ones in terms of a summary form. So f is defined between these specific intervals which we can give as closed intervals a and b given as such. And of course, we're going to see that this specific function of f, which we have given as such, we can describe it using its graphical representation using this specific aspect, whereby we're going to consider an interval given in terms of this specific range on the x-axis, which I've given in terms of x1 and x2, basically which I've just given above, which can generally be given as a and b. But in my case, I've just given them as x1 and x2 for the two graphs respectively. So we're going to consider the function in this specific term for a1 and a2 as I can give them, and try to see what is the difference between the two and how we can, what kind of wording basically we can use to define or try to differentiate the two. So for this function f, we're going to refer to it as increasing function over this specific range of x1 and 2. For this specific case, then therefore we can have it regarded as f is an increasing function when we have this specific intervals of x1 as smaller than or equivalent to x2, implying that the function of fx1 is basically smaller than or equivalent to the function of fx2 given as that one. And this is going to be giving us a specific relationship which we can use particularly in trying to define this first case of this representation whereby we have given for a1, and of course we're going to consider that one with the a2. So therefore, we're going to see that this specific nature of a function, we're going to have x1 being, of course, smaller than x2. And this is going to be defined by this specific increasing value in the x direction, which I've given as such. So for comparison of these two specific graphs, we will be regarding these specific intervals by an increase in the x direction given as such one. And of course, we're going to see that we can as well regard f as a decreasing function whereby we're going to have these specific intervals defined for the value of x1, of course, smaller than x2. So in the increasing x direction, then therefore we're going to have this value of x1 smaller than x2. But we're going to see that this is going to have an implication of the function of fx1 being, of course, so this is going to be the same for this. And the value of this one being greater than the function of fx 2 given as such. So this is going to be the interpretation for the second graph, whereby we're going to have these specific values for the interval of x1 being smaller than x2 or equivalent to that. And of course, we're going to have these specific values for the function of fx1, which is going to be this one, of course, smaller than, of course, greater than in value compared to this one. So if we have this going to be a Cartesian coordinate system, remember we can define a function as of course, a representation of two independent and dependent variables. So in this case, if we have y represented by the function of fx, then therefore these are going to be this respective range of these specific values for fx given in this specific term, which are the values of y. And therefore, in the second case, we are going to have this one as the value of y for x1 is going to be on a higher level compared to x2, and therefore this is going to depict for us a concept of a decreasing function. And in this case, we can as well compare another scenario whereby we're going to see change in this specific wording for the concept of increasing and decreasing functions. And that's going to be assisting us try to define the curves which we're going to come across, especially on different levels for other curves like the trigonometric function curves which we're going to come across. Now, in our case, I'm going to compare these two specific graphs, whereby we're going to have this graph of the function of this y is equivalent to 2x, and this is going to be a graph on the xy, of course, coordinates given as that one. And we're going to look at this one in contrast with another graph, which I can give in this specific form as the graph of, so this is going to pass through the origin. So this is going to be a graph of the function of y is equivalent to the square of x given as that. So if we compare these two graphs, we can define the basic aspect of the either increasing or decreasing function for these specific graphs. And if we consider this is going to be perhaps from the origin going in the positive x direction, then therefore we can give this particular graph as a strictly increasing. So there's a change of wording, strictly increasing function, which can be defined in terms of y is equivalent to 2x, or the function of fx is equivalent to 2x given as that one. So we can give this one as a strictly increasing function, and in terms of its intervals, we can define the intervals as the range for the positive r, where r is going to be, of course, a set of real numbers, and therefore this specific interval is defined for a set of values of x, where x is a set of real numbers, which are going to be defined between the range of x equivalent to, or of course greater than 0, which we can give in this specific form. And that is going to be giving us our interval for this specific aspect of a strictly increasing kind of a function. So if we try to compare that one with the set of a graph which we have given for y is equivalent to the square of x, we can give this one another definition of a function which is strictly decreasing. And this is going to be defined for the range of values of r, which is going to be negative, where r is a set of a range of real numbers which are going to be negative. And in this case as well, we can give a range of values of x, which are going to be a set of real numbers given as such. But in this case, this set of real numbers are going to be values whereby x is going to be equivalent or smaller than 0 given as such. So this two specific wording from our previous discussion, which we talked about the concept of increasing and decreasing functions, going to be giving us an additional concept on these basic values of either an increasing or a decreasing function. Now, suppose we have a combination of those specific graphs. I'm going to look at the case of this specific function for b, which I've just given on the lower side of the board given as such. So this is a graph of a trigonometric function, which is going to be defined by the graph of the concept or the function of the sine over x. So this is going to be y is equivalent to the sine over x given as such. So for this specific graph, we're going to see that various sections can either be defined from this specific concept, which we have given in terms of either strictly decreasing or strictly increasing. If we try to choose the first instance, which is going to be given in terms of strictly increasing we can choose a range of values for these specific intervals for the graph of that specific strictly increasing over a specific interval range, whereby we're going to see that for us we can choose this one. So from this specific point, we're going to have these specific graphs increasing along the x-axis given in this specific case, and this is going to be defined for a range of values which are going to be given as a half, a pi, and this is specific, of course, value for a positive pi given as such. And we're going to also choose a range of values which are going to be strictly decreasing in this specific curve of the sine function from this specific value of the range of values between a half pi, which is a positive, and of course 3/2 pi given as such. So this is going to be having a combination of the two ideas which we have basically given. And for the case of our application for these two specific concepts which we have said, of course, they are going to assist us in trying to be understanding the importance results which we are going to obtain from different graphs, which are going to be, or different functions which are differentiable. And this is going to be assisting us define a function as either, or determine whether a function is either increasing or decreasing. Now, one of the applications of this specific concept, as I said, is the mean value theorem, and with special case of Rolle theorem as well is going to be relying on this specific concept. And in our subsequent videos, we're going to look at these two specific cases, and they're going to be assisting us try to define, or rather try to analyze various kinds of graphs and their nature in terms of these specific decreasing or, and of course, increasing functions. So kindly check our description boxes for various links of other video. Get us in the comment section and also ring that notification bell for various updates on the concept of this specific aspect of integral and differential calculus. So that is it for now, guys. Bye, God bless you. Catch us in our next video.